Assalamualaikum. Today our group is going to present about the group assignment, which is our group member is me, Aiman Ashri, and we got Mohammad Farid and Mohammad Haqeemee. For introduction, I will present. The modern automobile has gone a long way since those simpler times. The advancement of tire design and construction, as well as improvement in suspension and enhanced strength and longevity of component, have all made significant contribution to the increased driving comfort and safety that have resulted from this development. The term sprung wheel refers to the radial wheel assemblies that make up this component. The wheel and tires, the brakes assemblies, and another structure parts that aren't supported by spring are all examples of unsprung wheel. Those are different kinds of such as torsion bar, air springs, coil spring, and leaf spring. These are typically installed on a vehicle in group of four, but they can also be paired off in a variety of alternative configurations. These are also variety of different mounting method that can be utilized for this purpose. Okay, the function of suspension, it protects the body of the car as well as the frame from the impact of the road. Second, it contributes to the vehicle overall stability. Third, it protects the passenger and the product of the vibration of the road. Fourth, it provides a secure grip on the road, which helpful when driving, turning, and braking. Fifth, it has an effect similar to the cushion. And lastly, it has a source of comfort. Okay, literature review, the advent of automobile, which are Daniel and Carlsbad developed independently of each other in 1886, established a completely new set of requirements in comparison of those that were associated with horse-drawn carriage. Gottlieb Daimler and Carlsbad came up with two very different solutions to this problem. Gottlieb Daimler vehicle was based on a carriage that was outfit with a steering system, where Carlsbad took a bicycle as a starting point for his patent motorcar that used a steering head and wire wheels. These are two significant advancements in the development of the engine, which became more powerful over time, making the automobiles faster while also making them heavier, a factor that posed a new challenge for the suspension. Design engineers' response consisted of solutions that were progressively more complex. Among these was a slowly but steady introduction of coil spring, which could be seen, or for instance, and on the back axle of the Daimler belt-driven car from the year 1895. At the turn of the 20th century, the chain drive was finally supplanted by shaft drive, which has been in use since 1909. Benz Parsifal, which was a forerunner of the Mercedes Simplex. Because of the new drive system, the entire assembly of the rear axle had been redesigned. Okay, there are several types of suspension that used in automobile industries. First is dependent suspension. This type of suspension system acts as a solid link between two wheels, such as any movement of one wheel, it transplants to the another wheel. Next is independent suspension. This type of suspension allows the system that travel without affecting the motion of the opposite wheel. And lastly, semi-independent suspension. A semi-active system has the ability to inflate the damping coefficient of damper, but the direction of the damping force is dependent on the relative velocity across the sprung and the unsprung mass. As you can see below, we got two pictures, which is dependent and independent suspension. Okay, task B.
So the task B, we choose three different types of car, which is SUV, sedan, and MPV. So the first car, we choose the Toyota Harrier. So the segment for Toyota Harrier, the type of front and rear suspension is, for the front Toyota Harrier is McPherson strut. For the rear suspension, Toyota Harrier is double wishbone. So the tire size for Toyota Harrier, it have two different types of tires, which are the size tire 225 slash 65 with radius 17, and the size tire 235 and 235 slash 55 with radius 18. So why they use the suspension and different tire size? For the first, Toyota Harrier is a SUV car, which means it need to be a McPherson straight suspension with the size of tire 17 and 18 radius. This is because the absorb of impact from the big size car has a large impact than small car. So the front suspension is better is use McPherson strut suspension that takes over the task of a steering rod and serve stimulus for suspension and vibration damping. The rear suspension Toyota Harrier double wishbone is good advantage with the size tire because suspension allows each wheel to set and react independently from the others. Next. For next, the segment B car is Protoativa, which is sedan car. So the type front suspension for Prodoa Beza is McPherson strut with coil spring, and the rear suspension for Beza is torsion beam. So the size tire of Prodoa Beza, it has two different size, which are 175/65S with radius 14, and it has 175/16S with radius 15. Last but not least, there are two more size tire, which are 185/55H with radius 15 and 185/50H with radius 16. So why they are use suspension? Why they Beza use this suspension and different size tire? Because product Beza is a sedan car, which a normal type of car most driver. This car also use front suspension McPherson strut with coil spring that normally average all sedan car. Size tire of product Beza, it helps as simplicity of the McPherson strut. It is a main advantage. Next. So the last segment for the car is Proton Israel, which is a MPV. So the type of front suspension for Izora is McPherson strut with stabilizer bar. So the rear suspension for Proton Izora is torsion beam. So size tire for Proton Izora is 205/55 with radius 16. It also have another size tire, which is 205/50 with radius 17. Why Proton Izora use this suspension and different tires? Because Proton Izora is a MPV car that mostly can carry a lot of passengers. Because of that, it needs to be a good suspension. Why this car use McPherson strut with stabilizer? This is because the size tire is required to this car, and if it need use that front suspension like McPherson strut with stabilizer that require less components to produce, which makes them cheaper to make, more lightweight and smaller than other types of suspension system. So the rear suspension for this car is use tension beam that carry passenger more. If this car has big impact, can absorb the impact more and safety. Alright.
Okay, next I will discuss about task C, that is discussion and suggestion. Okay, from the analysis that we had conclude in terms of improving the suspension of each vehicle that had been mentioned by Anas Farid, we suggested that the original system to be replaced with electronic control suspension. So what is electronic control suspension, or we also call it as ECS? So electronic control suspension is a computer controlled technology that can change how the car rides and perform. For a smoother ride compared to air suspension, An electronic suspension automatically adjusts the shocks and or started. The car's fundamental driving qualities can be altered, ranging from a comfortable soft ride to a sporty, challenging drive, and everything in between. Everything should move swiftly and continually. By pressing a button, the driver can choose to manually switch between the sport, normal, and comfort driving mode. The electronic control suspension, worked by an internal solenoid valve, controls the unit's hydraulic fluid flow by receiving instruction to open or close from an electronic link to the strut or shock. Electronic control suspension consists of two types: adaptive or semi-active and a fully active. For adaptive, or we call it semi-active process, it regulates the shock or strut rate of compression and rebound, providing a softer or stronger ride as needed. Fully active system is significantly more difficult to replace and more expensive. It consists of utilizing of magnetically charged metal particle inside the stud or shock, along with more sophisticated computer and vehicle sensors. Is a feature of this system. A harsher or stiffer ride result from the metal particle increase in the viscosity of the hydraulic fluid inside the strut or shock when an electric current controlled by the computer system is passed through it at a higher rate. Metal ion inside the shock or strut evaporated when the electric current stopped, letting the fluid flow easier and ride softer. The electrical control suspension usually consists of ECU, electronic control unit, adjustable shock and a spring, a series of sensors at each of the vehicle wheel, an actuator or servo atop of each shock and spring. These are the fundamental components of an active suspension. They may vary significantly between manufacturers. The ECU collect data, analyze it, and then interpret it, continuously monitoring change in the road surface and communicating the information to the remote component via the ECU is how active suspension work. There is no longer any trade-off between comfort and handling. It is both soft and firm as needed. Each of the four absorbers is separated, controlled by the electronic control suspension, enabling millisecond alteration for a better ride. The body to the wheel displacement, the steering angle, vehicle speed, pitch, and other input are all under the control of the ECS. These input are evaluated by an ECS module, which result in an improved ride and comfort level through a wide variety of operation situation. Each shock absorber has an ECS module that provide electronic control logic and output drive. The information about the load, the road, and driving condition obtained from numerous input is used by the ECS module to make decision. So our group suggesting that the original system is replaced by the electronic control suspension for the vehicle to work even better. Okay, that's all from us. Thank you very much. Hello.